Alright guys, so now we are going to work with the section 1.6 and we are going to try to do the problem number 1, page 71. So page 71, problem number 1. In this problem number 1, what do we have? So in this problem number 1, what do we have? We're having an acid solution, and they are telling you that if 40 liters of an acid solution, so we have an acid solution, volume equal 40 liters at 75% acid, okay? How much pure acid is there in the mixture? Question, how much pure acid is there in the mixture? Well, to do that is pretty simple. You are going to take 75% multiplied by 40 liters, and you are going to end up to have the value of how much pure acid is there in the mixture. And its question is going to be 30, and the answer is going to be 30 liters. Okay? Pretty simple, pretty easy. Problem number 2. If I look at the problem number 2, it's about direct variation. And if y vary directly with x, so k times x, and y equal to, when x equal 4, what is the value of y? When x equal 12. Well, to solve this problem, it's pretty simple. First of all, if you want to find y, like the question is asking you, find the value of y, based on the formula you have, to find y, you need to know k and x. They are telling you, find y when x equal 12. So you have x, but you don't have k. To find k, you are going to use the other information they are giving you. So, first of all, the question is y equal k by x. What is the value of y? K equal, question mark, x equal, and I think we said it was 12. So obviously I'm missing k. Well, to find k, you are going to go back to this expression and express k by putting k by himself, dividing by x both sides, and you end up to have k equal y over x. That said, now you're going to say, I know that x equal 2, x equal 4, and y equal 2 are going to be the two values of x and y I'm going to use to find k. When I do that, I end up to have k equal 2 divided by 4, which is 1 over 2. Now I know the value of k. K equal 1 over 2. And so now I can calculate y, because y is going to be equal to 1 over 2 multiplied by 12. Y is going to be equal to 6. Okay? Alright, so now what I want to go back is to the example number 2 in your book, page 67. I want to go back to this example because this is exactly what you will have to do when you want to solve the problem, solving problem about mixture of concentration. So the question is, how much pure alcohol should be added to 20 liters of 40% alcohol to increase the concentration to 50%? Every single time you have to solve a problem, you need to represent the problem in a different way. So how would you do that? By looking and transforming the sentence, actually the question, how much pure acid should be added to 20 liters? Well, you are going to have a little box when you have 20 liters at 40% of alcohol, and then should be added. So should be added is going to be translated into a mathematical language with the plus to increase the concentration. So how much would be added? You don't know, and you are going to call X the volume of alcohol pure, so which means it's 100% alcohol, and you know that it's going to help you to have a 50% solution. And what will be the new volume? Well, the new volume is going to be X plus 20. And now it's pretty easy, because the only thing you have to do is 0.4 multiplied by 20 plus 1 multiplied by X equal 0.5 multiplied by X plus 20. Okay? And once you have that, you just need to multiply. You are going to multiply 0.4 by 20, it's going to be equal to 8, plus 1x equal 0.5x plus 10. And then you need to isolate x. So you are going to subtract by 0.5x both sides. And you are going to subtract 8 both sides. By doing so, what is happening is now on the left side of your equation, you have only numbers. In that case, 10 minus 8, which is going to be equal to 2. And on the other side, you are going to have negative 8, and the other side, you are going to have 1 minus 0.5, which is 0.5x. So far, x is going to be equal to 2 multiplied by 2, which is 4. So you need to add 4 liters of 100% pure acid in order to 20 liters 40% acid, in order for you to have 50% of a solution, to have a solution made of 50% of acid. Alcohol, I'm sorry, about alcohol. It was about alcohol. All right, thank you very much. All right, guys, so now let me go back to the problem number 20, and you will understand why I was confused between acid and alcohol. Because on the problem number 20, you have Bill Charlson needs 10% hydrochloric acid for a chemistry experiment. So, we are in need of a 10% hydrochloric acid. Okay? How much 5% acid? So, how much 5% acid? So, I don't know how much. I'm going to call that X of 5% acid should be mixed, so should be had, plus to a 60 milliliter of 20%. Now it is a 60 milliliters of a 20% acid, okay, to obtain equal 10% solution. So to obtain 10% solution. So I'm going to obtain a 10% solution, and obviously the volume is going to be X plus 60. So, well, I'm going to apply what I've done on my example number 2. What I'm going to do is I'm going to say 0.05 for 5% multiply by X plus 60 multiplied by 0.220 equal X plus 60 multiply by 0.1 or 0.10. That gives me a 0.05x plus 12 equal 0.1x plus 6. Okay? Now, I'm going to subtract by negative 0.05x both sides. Oops, I'm just going to erase that. So I'm going to subtract by 0.05x both sides. Why do I do that? Because by doing this, I'm getting rid of on one side the x, and I will have x only on one side. Because I'm looking for isolate x, I need to get rid of the 6, so I'm going to subtract by 6 both sides, and I end up to have 6 equal 0.05 x. And now if I want to find x, I'm going to divide by 0.05 both sides, and I will have x equal, so it is a 6 divided by 5 over 100, so that it is the equivalent of 6 multiplied by 100 divided by 5. So now we got 600 divided by 5, and that is equal to 120. So the volume that I will need to add, x, is going to be 120 milliliters. Okay, since I've been working in milliliters, the volume that I will have to add is going to be 120 milliliters.